writing equations in slope-intercept form. So up until now, we have been given an equation and we've figured out a table and then we've graphed it, or we've graphed it using the slope and the y-intercept. Now we're going to go backwards. So we'll be given a graph, or we'll be given some ordered pairs, or we'll be given a word problem, and we're going to create the equation from that particular situation. So remember, our equation that we've been really using most often has been y equals mx plus b. M is the slope, b is the y-intercept, and don't forget that the x and the y represent a coordinate that fits that particular equation, a coordinate in a table or a coordinate that we eventually put as a point on a coordinate plane. So what we're going to do is we're going to do basically two things. We're going to find the slope and we're going to find the y-intercept. And there's a few ways to do each of those, but we want to find the slope, we want to find the y-intercept, and we want to plug them into the equation. So let's work from this graph here. I have 2 points. I have 0, 2, and I have 1, 4. First, to find the slope. Now since it's a graph, I could use the slope. I could use rise and run. That would be totally fine. I want to get some practice using my slope formula here. So I'm going to refresh myself as to my slope formula. y2 minus y1 over x2 minus x1. So I'm going to plug my first ordered pair, 4, 1, y over the x. Then I'm going to plug in some subtraction signs. Then I'm going to do my second ordered pair, again, y over x. And I'm going to do the subtraction. I get 2 over 1, or 2. So my slope is 2. Again, if I did rise over run here, I'd get a rise of 2, a run of 1, which is 2 over 1. That's a positive line, so a positive slope makes sense. So my equation is starting to look like y equals 2x plus b. I still don't know what my y-intercept is. Remember, the y-intercept is the beginning. It's where this line starts, and we think about where it starts as on the y-axis. So we can look on the graph. So on my graph here, I see that my y-intercept on the y-axis is at 0, 2. So I could use 2 as my y-intercept. I could also do it from the ordered pair, 0, 2. I know this is the y-intercept because my x value is 0. So I know a second way that the y-intercept is 2. But if I'm not given that obviously, another way I can do that is by substituting xy, one of my ordered pairs, and m, which is my slope that I already found, into the equation to find my y-intercept, my b. So here I have a slope of 2. I figured that out earlier. And here I have an ordered pair. I'm going to use 1, 4, just because it's relatively friendly to work with. I'm going to use 1, 4. So here's my equation, y equals mx plus b. I'm going to take out my y value and put in 4. I'm going to take out my m value for my slope and put in 2. And I'm going to take out my x value, the one that goes with the one I already used, my 4, and I'm going to plug that in. Now I don't know my y-intercept, so the b stays in the equation. So I've got a y equals an m times an x plus a b. Now I'm going to do the math to isolate the b. So 2 times 1 is 2. I need to subtract 2 from both sides to get the b by itself. I end up with b equals 2, which I should, because I know that the y-intercept is 2 from the graph. I know it's 2 from the ordered pair. So it should be 2 if I do it this way also. I don't have to do it all 3 ways. I only need to do one way. Sometimes this is the only way to get to it. So my equation looks like y equals 2x plus 2. Remember, our equations should have y's and x's in them. It should have those variables because those hold the place of the ordered pairs. And remember, there are an infinite amount of ordered pairs on that line. So the x and the y stay in the equation, but the slope is a number because it's describing how steep the line is. And the y-intercept is a number because it's describing where this line crosses the y-axis. The y and the x, there's an infinite amount of ordered pairs on that line, so I can't plug them all in. So I just leave the x and the y as placeholders. So there's the equation that matches that line. All right, let's try a couple more. So we have another graph here. I have 2 ordered pairs. First thing I'm going to do, find the slope. I'm going to use my slope formula here. Again, I could use rise over run, that's fine. My slope formula, I get negative 4/3. It's a negative line, that makes sense. My y-intercept, I'm going to find that right from the graph this particular time. So I have 0, negative 1. So I have a y-intercept of negative 1. I can also find that from the ordered pair. 0 is x, so my y-intercept is negative 1. So my equation looks like y equals, I'm going to plug in my slope of negative 4/3 times x minus 1. Again, the x and the y stay in there because they're holding the place of all the ordered pairs on that line. The slope describes how steep it is, and the y-axis, the y-intercept describes where it crosses the y-axis. Number 3. Now this is one of those weird lines, and you should look at this horizontal line and immediately bells and whistles should go off in your head because you recognize that this is one of those weird slopes. It's a weird line, vertical, horizontal, so it's one of those weird slopes, either 0 or no slope. And if we think about this line going this way, I can ski on it. This is not a trip to the emergency room. I can ski on it, except my speed is pretty slow. It's actually 0. So since my slope is 0, I'm going to use 0 for my slope. I could have also used the slope formula. That would work. Or I could use rise over run. So there's a few ways I could come up with a slope of 0. My slope is 0. My y-intercept is where it crosses the y-axis, right here at -4. So my y-intercept is -4. So this equation looks like y equals 0x, 0 is my slope, minus 4, -4 is my y-intercept. And 0 times x is 0, 0 minus 4 is -4, so I end up with an equation of 0 equals -4. All right, last one, which may or may not be on the paper that you're looking at in front of you. We're going to use just the ordered pairs, so no more graph. So we're going to have to do this all with algebra. So two ordered pairs, 1, 1, and -1, -3. I'm going to use my slope formula, and I'm going to plug in those ordered pairs, and I come up with a slope of 2. So now I have a slope of 2, and I'm going to use one of my ordered pairs. I'm going to use 1, 1, since it's not negative numbers. I don't want to use those negative numbers. So I'm going to use m equals 2, x will equal 1, and y will equal 1. I'm going to go back to my equation, y equals mx plus b. I'm going to plug in a y value as 1. I'm going to plug in an m value as 2. And I'm going to plug in my x value as 1 also, because I'm using that ordered pair 1, 1. Plus b, I still don't know what the y-intercept is yet. I'm going to do my algebra here, and I come up with b is equal to -1. So I have the two things I needed. I needed a slope, and I needed a y-intercept. So here's my equation, y equals 2x plus -1, or you could write it -1, that's fine too. Remember, this equation is describing what this graph looks like if I was to put it on a coordinate plane. So it has a slope of 2, positive line, and it crosses the y-axis at -1, just below the origin. This equation, I should be able to use this equation to come up with ordered pairs. So I could say to you, hey, could you graph this equation for me? And if you use these x values, you should get these ordered pairs. So I'm going to check them. This is a nice, easy way to check to see if your equation is actually correct. I'm going to plug 1 in for x and see what I get for a y. So 2 times 1 equals 2, plus -1. 2 plus -1 is positive 1. Yes, so when I put in 1 for x, I get 1 for y. Let's try it with -1. 2 times -1 is -2. -2 plus -1 is -3. So I should have a y equals -3. That totally works. So these ordered pairs should work with this equation if this equation accurately describes the line that goes through those 2 points. So again, to write an equation in slope-intercept form, I need the slope and I need the y-intercept.